Welcome to the Olusegun Math Clinic, where we solve mathematical problems and questions, and for a better and simple explanation. This is a third degree questions, and it's a radical and a little bit a complex exponential problem. We talked about 2 raised to power x plus 4 raised to power x plus x raised to power x equal to 39, and the value that we need is x, and x is an element of real number. So for the fact that x is an element of real number, so what exactly we are going to do? So we need the power of a radical equations, that is the indices, the powers of indices to apply to this level of equation, whereby which we talks about that this 2 raised to power x can be rewritten to have 2 raised to power x. Let me try to make it bold. 2 raised to power x plus, 4 can be written as 2 raised to power 2, or raised to power x, plus 8 can be written as 2 raised to power 3, or raised to power x is equal to 39. So there's still the power of index that we still need to put in place. Recall, there is a law that says that a raised to power m at the same time raised to power n can be written as a raised to power m times n. At the same time can be written as a raised to power n or raised to power m. You discover that this is m, is inside here, but this is m, it is outside here. So let's also apply it to this equation. So therefore we have 2 raised to power x plus 2 raised to power x all squared plus 2 raised to power x all raised to power 3 is equal to 39. So this is how it looks like. So therefore, let's try to make a as a subject of the formula to say a is equal to 2 raised to power x. So if a is equal to 2 raised to power s, let's try to substitute the value of a. So a is equal to 2 raised to power x. Let's now try to substitute the value of a. So we have a plus a square plus a raised to power 3 is equal to 39. This is the third degree equation. But let's try to rearrange the value of this equation very well to say a raised to power 3 plus a square plus a is equal to 39. Now, having this equation like this, I want you to understand one fact, that recall that this a, I will also let you know the secret. I'm trying to apply some logical terms here. That logical terms is what we need to apply to any Diophantine equation. So these logical terms that I want to use, let's try to reason. This a can be written as a raised to power 3 minus 3a square plus 4a square. By the time you add these two, it will give you a square. Now, let's also try to expand this a. This a can be giving us minus 12a plus 13a is equal to 39. Please, before I go further, how do I know to write 3a squared plus 4a squared? The first logical thing is that will make you to know is this. What can also give you a square, it will be minus 3a squared plus 4a squared. I will now find a number that can be a factor of 39. That is my first assignment. And also, I will find a factor that this 4 will also go by the time I add them together. That is why I put 12 here, 13. I can't put 13 here. I will now rewrite to say a raised to power 3 minus 3a square plus 4a square minus 12a plus 13a minus 39 is equal to 0. So let's try to group them. A raised to power 3 minus 3a squared. We'll try to group them. Plus 13a minus 39 is equal to 0. So for fact I'm grouping them now. A squared is common here. We have a minus 3 plus 4. A is common here. We have a minus 3 plus 13 is common. We have a minus 3 is equal to 0. But a minus 3 is common. We have a minus 3 is common around a squared plus 4a plus 13 is equal to 0. So since any two numbers being multiplied together is equal to 0, it means a minus 3 is equal to 0, or a squared plus 4a plus 13 is equal to 0. So a is equal to 3, or a squared plus 4a plus 13 is equal to 0. So before we proceed, you know, from the question we said our x is a real number. So if our x is a real number, let's first cross-check. Maybe this value can have a factor. That's first thing to do. Let's cross-check. Maybe it will have a factor. So if it doesn't have a factor, it's a complex number, we ignore it. So if a squared plus 4a plus 13 is equal to 0. So our, from quadratic formula, a is equal to 1, b is equal to 4, and c is equal to 13. So let's apply the formula to it. So we apply the formula to have our a is equal to minus b plus or minus square root of b squared minus 4ac over 2a. So if we want to find the value of a, the moment if this one is minus, it means it's complex. We have to ignore. So therefore, our b is 4. We have minus 4 plus or minus. So b is 4 squared minus 4ac over 2a. So therefore, a will be minus 4 plus or minus. So we have 16 minus. So let's try to multiply. So let's multiply 4 times 13 give you 52. So if you're able to see this area, you discover that it will give you minus, because it will now have a is equal to minus 4 plus or minus square root of. So let's try to subtract minus 16. So we have minus 36. So over 2 onto 1. So this one is a complex number. So complex form. So it means we have to ignore the value of this equation because it forms a complex. But recall that our a is equal to 3. So we have to obey the value that a is equal to 3. So therefore, a is equal to 3. Now, recall that, and we represent a to be 2 raised to power x. So let's try to put it together to have 2 raised to power x is equal to 3. So let's apply log to have log 2 raised to power x is equal to log 3. So, which we have x log 2 is equal to log 3. So, the value of our x will now be s is equal to log 3 divided by log 2. So, and for changing of base, it can be written as log 3 base 2. So, and log 3 base 2 So by the time we try to apply with calculator, we're able to see that the answer, the approximative value, is equal to 1.585. But this is not where we are going to. Let's now cross-check the value of our answer. Maybe it is correct or not. Let's try to cross-check. So in the process of cross-checking, you know that 2 raised to the power x plus 4 raised to the power x plus 8 raised to the power x is equal to 39. And our s is equal to log 3 base 2. So let's apply to have 2 onto 2 raised to the power. Our s is log 3 base 2 plus 4 log 3 base 2 plus 8 raised to the power log 3 base 2. So we want to prove maybe it is 39 to know maybe our answer is correct. So therefore we have 2 log 3 base 2 plus 2 square log 3 base 2 plus 2 raised to the power 3 log 3 base 2. So we try to apply another law of logarithms that says that if n log p base a, it will give you log p raised to the power n base a. So therefore, since we obey this law, mean that 2 raised to the power log 3 base 2 plus, record that these two we come up, it will give you log 3 square base 2 plus 2 raised to the power log 3 raised to the power 3 base 2. So therefore, let's try to rewrite it. 2 log 3 base 2 plus 2 raised to the power log 9 base 2 plus 2 raised to the power log 27 base 2. There is a law of logarithms that says that a raised to the power log k base a, the value is k. So you have to understand this law. So for the fact that you understand this law now, so you have to apply to this. So therefore, 2 raised to the power log 3 base 2. So it means since they are the same, the answer here is 3 plus this one also 2 base, this one is to be 9 plus 2, these are making 27. So which give us 3 plus 27 making 30 plus 9. So making 39. So the final answer, so meaning that our final answer is now correct, that s is equal to log 3 base 2. So don't forget to subscribe and like and share this video, and like our page for the next video that we are releasing to this page. Yeah, thanks for watching and stay tuned.